This lecture will talk about the basic process by which data analysis will unfold. And of course, not every data analysis is the same, and not every data analysis will require the same components. I think this will serve as a useful template for kind of understanding what are the pieces of a data analysis and how they typically flow together. So if one were to write down the steps in a data analysis, you might come up with something along these lines, a list just like this one. There may be little things you might want to add or delete. Most data analyses have some subset of these steps. And so what we're going to talk about in this lecture, which is part one, is defining the question that you're interested in, defining the ideal data set, determining what data you actually can access, obtaining the data, and cleaning the data. And then in part two of this lecture, we'll talk about the remaining topics here. I think the key challenge in pretty much any data analysis was well characterized by Dan Meyer, who's a mathematics educator and taught high school mathematics. And in his TED Talk, he said, ask yourselves, what problem have you solved ever that was worth solving where you knew all the given information in advance, where you didn't have a surplus of information and have to filter it out, or you had insufficient information and had to go find some. And so I think that's a key element of data analysis, which is that typically you don't have all the facts, or you have too much information, and you kind of have to go through it. And a lot of the process of data analysis is sorting through kind of all this stuff. And so the first part, the kind of important part of data analysis that you want to start with is to define a question. And not every data analysis starts with a very specific or coherent question. But the more effort you can put into coming up with a reasonable question, the less effort you'll spend having to filter through a lot of stuff. And the reason why is that defining a question is the most powerful dimension reduction tool you can ever employ. Because if you're interested in a specific variable, like height or weight, then you can kind of remove a lot of other variables that don't really pertain to that at all. But if you're interested in a different type of variable, then you can remove another subset. And so the idea is if you can narrow down your question as specifically as possible, then that will serve to reduce the kind of noise that you'll have to deal with when you're going through a potentially very large data set. Now, sometimes you just want to look at a data set and see kind of what's inside this data set. And then you'll have to explore all kinds of things in a large data set. But if you can narrow down your interest to a specific type of question, then that can be extremely useful for simplifying your problem. So I encourage you to kind of think about what type of question you're interested in answering before you go into delving into all the details of your data set. So the science, generally speaking, will determine what type of question you're interested in asking. And that will lead you to the data, which may lead you to applied statistics, which is you use to analyze the data. And then if you get really ambitious, you might want to think of some theoretical statistics that will kind of generalize the methods that you apply to different types of data. Now, of course, there are relatively few people who can do that, and so that would not be expected of everyone. So the part that's in the red bracket, that's number one. That's typically referred to as statistical methods development. The part that's in the purple bracket here, number two, which is just the application of statistics to raw data without any sense of science, is what I would refer to as the danger zone, which I kind of derive here from a kind of a Venn diagram of data science that was written by Drew Conway. The idea is that if you just kind of randomly apply statistical methods to data sets to find an interesting answer, first of all, you will find something interesting, almost certainly, but it may not be reproducible and it may not be really meaningful. And so I think a proper data analysis has a scientific context. It hopefully has at least some general question that we're trying to investigate, which will narrow down the kind of dimensionality of the problem. And then we'll apply the appropriate statistical methods to the appropriate data. So let's start with a very basic example of a question. So a general question might be, can I automatically detect emails that are spam and those that are not? Of course, this is an important question if you use email. You want to know what are the emails that you should read that are important, and what are the emails that are just spam. And so you might want to. So if you want to turn that into a data analysis problem, there are many ways that you could answer this question. For example, you could just hire someone to just go through your email and figure out what's spam or not. But that's not really. That's probably not very sustainable. It's not particularly efficient. So if you want to turn this into a data analysis question, you have to make the question a little bit more concrete. and translate it into, by using terms that are specific to data analysis tools. And so a more concrete version of this question might be, can I use quantitative characteristics of the emails themselves to classify them as spam or ham? Okay, so now we can start looking at emails and try to think, well, what are these quantitative characteristics that I want to develop so that I can kind of classify them as spam? So once you've got a question here, we want to know, okay, well, how do I separate out my email so that I know what's spam and what's not spam? So that way, presumably, you can kind of get rid of all the spam and just read the real email. So the first thing you might want to think about is, what's the ideal data set for this problem? And so if I had, all the resources in the world, what would I go out to look for? And so there are different types of data sets that you could potentially collect. And depending on the goal and the type of question you're asking. A descriptive data set, so if you're interested in a descriptive problem, you might think of a whole population. So you don't need to sample anything. You might want to just get the entire census or population that you're looking for, so all the emails in the universe, for example. If you just want to explore your question, you might just take a random sample with a bunch of variables measured. If you want to make inference about a problem, then you have to be very careful about the sampling mechanism and the definition of the population that you're sampling from, because typically when you make an inferential statement, you're drawing from a sample to make a conclusion about a larger population. So there, the sampling mechanism is very important. If you want to make a prediction, then you're going to need something like a training set and a test data set from a population that you're interested in, so that you can build a model and a classifier. If you want to make a causal statement, so you want to say, okay, if I modify this component, then something else happens. So this is basically, you're going to need experimental data, and one type of experimental data is from something like a randomized trial or a randomized study. And then if you want to make mechanistic types of statements, you need data about all the different components of the system that you're trying to describe. So for our problem here with spam, one ideal data set perhaps would be, if you use Gmail, you know that all the emails in the Gmail system are going to be stored on Google's data centers, right? So why don't we just get all the data in Google's data centers, all the emails in Google's data centers, right? Because that would be a whole population of emails, and then we can just kind of build our classifier based on all this data, and then we wouldn't have to worry about sampling because we'd have all the data. And so that would be a kind of ideal data set. So, of course, in the real world, you have to think about, well, what are the data that you can actually access, right? So maybe someone at Google can access all the emails that go through Gmail, but even in that extreme case, it may be difficult. And furthermore, most people are not going to be able to access that. So sometimes you have to go for something that's not quite the ideal data set. And so you might be able to find free data on the web. You might need to buy some data from a provider. And in these kinds of cases, you should be sure to respect the terms of use for the data. So any agreement or contract that you agree to about the data has to be adhered to. And if the data simply just do not exist out there, you may need to generate the data yourself in some way. So getting all the data from Google will probably not be possible, just because I'm guessing their data centers have some very high security, and so we're going to have to go with something else. And so one possible solution comes from the UCI machine learning repository, which is the spam-based data set. And this is a collection of spam and this data set was created by people at Hewlett-Packard who collected a couple thousand spam messages, spam and regular messages, and classified them appropriately. So you can use this database to explore your problem of how to classify emails into spam or ham. So when you obtain the data, the first goal is to try to obtain the raw data, for example, from the UCI machine learning repository. You have to be careful to reference the source. So wherever you get the data from, you should always reference the source and keep track of where it came from. If you need to get data from a person or an investigator that you're not familiar with, often a very polite email will go a long way. They may be willing to share that data with you. And if you get data from an internet source, you should always make sure at a very minimum to record the URL, which is the website indicator of where you got the data, and the time and date that you accessed that, so people have a reference of when that data was available. In the future, the website might go down, or the URL may change, or may not be available, but at least at that time that you got the data, you documented how you got it. So the data set that we're going to talk about in this example, since we don't have access to Google's data centers, is the spam email data set, which you can get from the KernLab package in R. So it comes with the KernLab package, and so if you install the KernLab package, you can load the data set right away. So the first thing that you typically need to do with any data set is to clean it a little bit. So often, raw data you typically needs to be processed in some way to get it into a form where you could model it or kind of feed it into a modeling program. If it's already pre-processed, it's important that you understand how it was pre-processed. So try to get some documentation about what the pre-processing was and how it was done. You have to understand kind of where the data come from. So for example, if it came from a survey, you need to know how the sampling was done. Was it a convenience sample? Did the data come from an observational study? Did it come from an experiment? So the source of the data is very important. You may need to reformat the data in a certain way to get it to work in a certain type of analysis. If the data set is extremely large, you may want to subsample the data set to make it more manageable. And so anything that you do to clean the data, it's very important that you record these steps and write them down in a script or whatever is most convenient. Because you or someone else is going to have to reproduce these steps in order if they want to reproduce your findings. And if you don't document all these pre-processing steps, then no one will ever be able to do it again. So once you've cleaned the data and you've gotten a basic look at it, it's important to determine if the data are good enough to solve your problem. Because in some cases, they may not be good enough. You may not have enough data. You may not have enough variables or enough characteristics. The sampling of the data may be inappropriate for your question. So there may be all kinds of problems that occur that you realize as you clean the data. And so if you determine that the data are not good enough for your question, then you've got to quit and try again, or change the data, or try a different question. It's important to not to just simply push on with the data that you have just because it's all that you've got, because that can lead to inappropriate inferences or conclusions. So here's our clean data set that we're going to use for this example. It's already been cleaned for us in the KernLab package, and I've just shown you the first 5 variables here. There are many other variables in the data set, but you can see that there's 4,601 observations of the 5 variables. And I put the link here. You can see the help page that shows you where the data set came from and how it was processed.